Truth is simple, very simple, so simple that a child can't understand it. In fact, so simple that only a child can understand it. Unless you become a child again, you will not be able to understand it. Osho. Good morning. Here's my second show of the day, and I think it might stop here for a while until I go on and do a little bit more, maybe later on tonight. Again, I have quite a bit of things. Oops, I think this is better. To do topics on. I didn't add this one in. I just thought, hey, I just thought about this one. Let's do this one. So this one kind of goes aligned with the Archimedes principle and gravity. Have a 2040-year problem, but it not necessarily because of this. It is because of this. Because of doing this and looking up 2048, when I look into numbers, I look into, does it have any significance? Why is there a 2040-year gap? Is that coincidence or synchronicity, whatever you want to call it? Well, anyways, I thought I'd just go over it. So when I was looking into it, I was looking over, I found it here, 2048. And what 2048 is, if you don't recognize these sequences numbers, it's the Fibonacci sequence or the golden mean. You can go and look into that, but basically it's going to just kind of add up the numbers using digital, I forgot, what do you call it? It's a digital addition or something like that. But basically you get two numbers and you add it up to become a single digit. So for example, the Fibonacci sequence goes to 16. 1 plus 6 is 7. 3 plus 2 is 5. The next number in the sequence is 32. It's just doubling it. And 3 plus 2 equals 5. Double the previous number is 64. 6 plus 4 is 10. 1 plus 0 is 1. And then double that, you get 128. 1 plus 2 equals 3. 3 plus 8 equals 11. 1 plus 1 equals 2. So you see how that goes. I did this in my intro to numerology. I did a couple months back. You could go and revisit that. It kind of goes over that. I think, let's see, this is the end of it. And I'll go over 72 and 73 again. And let's see. Let's see, where did I find it? I get over a lot of stuff. Digital? Nope, I don't have it there. It's a certain, I should have mentioned it earlier. If I didn't, I am sorry. Let's see. Okay, no, that's not it. Anyways, I should have gone over it before. If I didn't go over it before, now you know what it is. And oh wait, maybe I'm not thinking of Fibonacci sequence. I'm thinking of doubling. Sorry, I'm getting things wrong. I'm sorry. I'm trying to go fast because there's so many things that I want to do today, and hopefully I can get to it tonight. So this is just the doubling of the numbers. It's not the Fibonacci sequence. I don't know why I was thinking that, but all right. Now when you get the doubling of all the numbers, what do you get? You get 1 plus 2. Well, you get 1, 2, 4, 8, 7, 5. You keep doing this, you get 1, 2, 4, 8, 7, 5. 1, 2, 8, 4, 8, 7, 5. 1, 2, 8, 4, 8, 7, 5. 1, 2, 8, 4, 8, 7, 5. 1, 2, 4, 8, 7, 5. All right, you get the idea. Now, 1, 2, 8, 4. 1, 2, 4, 8, 7, 5. What's interesting about those numbers is it doesn't include 3, 6, or 9. But if you add the first two numbers together, 1 and 2, you get 3. And the digital, I don't know what you call it, digital addition, whatever it is. You get 4 plus 8 equals 12. 1 plus 2 equals 3. And you get 7 plus 5 equals 12, which is 1 plus 2 equals 3. So 3, 3, 3. 3 plus 3 equals 6. 3 plus 3 plus 3 equals 9. So you get 3, 6, 9 in that. Interesting. All right. Now, this blog world-mysteries.com. You can go look at it. It's in the link if you're watching through YouTube, or if you're looking through vim.tv, which is ends up being resulted in Steam. So if you go to my Steam page, you will see all the description box information. Now this person, take it or leave it, this is the information that's being presented. At this point, you might be thinking, what in the world do these number patterns have to do with real world applications? These number groupings piece together into a jigsaw-like puzzle pattern that perfectly demonstrates the way energy flows. Our base 10 decimal system is not man-made, rather it is created by this flow of energy. Amazingly, after 20 years working with the symbol and collaborating with engineers and scientists, Marco discovered that the 124875 was a doubling circuit for a very efficient electrical coil. There was still one more very important number pattern to be realized. On the mathematical fingerprint of God, notice how the 3, 9, and 6 is in red and does not connect at the base. See, this is the yin yang symbol, 369, or Tao symbol as well. That is because it is a vector. The 124875 is the third dimension, while the oscillation between the 3 and 6 demonstrates the fourth dimension, which is the higher dimensional magnetic field of an electrical coil. The 3, 9, and 6 always occur together, with the 9 as the control. In fact, the yin yang is not a duality, but rather a trinary. This is because the 3 and 6 represent each side of the yin yang, and the 9 is the S curve between them. Everything is based on thirds. We think the universe is based on dualities because we see the effects, not the cause. Interesting. We'll probably go into more of that later. Okay, so the Titus-Bode law and Pascal's triangle. This is more, again, looking into the information provided of the globe Earth model. The globe Earth model, the official narrative that the Earth is a globe, superimposes that we assume that the Earth is a globe, therefore the Earth is a globe. And all the math behind it is based off of that. Now, when we look into Titus-Bode law and Pascal's triangle, here it states in 1768, Bode published his popular book, Instruction for the Knowledge of the Starry Heavens. In this book, he described an empirical law on planetary distances, originally found by J.D. Titius, now called Bode's law or Titus-Bode law. Titius-Bode law, sorry. Titius, haha. All right, so if you look at Bode's law, you'll see Bode's law. I clicked on the first link, and you're going to see it here. And I'll just go ahead and erase those and look in here. So look at Bode's law in astrosun2.astro.cornell.edu. This is Cornell, by the way. It's not just some random conspiracy article. All right, Titus-Bode law is a rough rule that predicts the spacing of the planets in the solar system. How interesting, huh? The relationship was first pointed out by Johann Titius in 1766 and was formulated as a mathematical expression by J.E. Bode in 1778. The dates keep being wrong. I don't know why. Or at least they're not wrong, but they're different from every source that I see. So this is Bode's law is first found in David Gregory's The Elements of Astronomy, published in 1715. And so a lot of these dates are just really, really weird. At any rates, if I go by the Bode's law, is that in astronomy at Britannica.com, this is the third result. You know, this is what I wrote in my Globe Earth declarations. And I got the rest of these body actual distances of Bode's law, which we'll go over in just a second later. But basically, Bode's law, also called Titius-Bode law, empirical rule, giving the approximate distances of the planets from the sun. It was first introduced in 1766 by the German astronomer Johann Daniel Titius, but was popularized only from 1772 by his countryman Johann Elliot Bode. Once suspected to have some significance regarding the formation of the solar system, Bode's law is now generally regarded as numerological curiosity with no known justification. Now, we're going to get more into this later. I think it's just easier for most people to see it just written down in a formula. Here, the original formula was A equals n plus 4 divided by 10, where n equals 0, 3, 6, 12, 24, 48, 96, 192, 384. And you're going to, if you look into it more, you'll see that one way to state Bode's law begins with a sequence 0, 3, 6, 12, 24, in which each number after 3 is twice the previous one. So that's where we get the numbers to implement within the numbers presented here, right? These are the numbers. Okay, to find the mean distances of the planets, begin with the following simple sequence of numbers: 0, 3, 6, 12, 24, 48, 96, 182, 384. These numbers after 0 derived from the Pascal's triangle as the sum of a row added to the sum of the previous row. So row 1, 2 plus 1 equals 3, 4 plus 2 equals 6, 8 plus 4 equals 12, 16 plus 8 equals 24, etc., etc. And that's where it was explained right here. Next, add 4 to each number, and we're going by this equation, n plus 4, and you divide it by 10. Next, add 4 to each number, and you will get 4, 7, 10, 16, 28, 52, 100, 196, 388. And again, it's in Britannica.com. It gives you the answers, first 7 answers, which is 0.4, 0.7, 10, 1, 1.6, 2.8, 5.2, 10. Okay, because Britannica did it all already. So then, because this one, you're going to have to divide it, and you get those same numbers as the Britannica.com. Are you going to say Britannica.com is wrong? No, you're not. Probably not. If you are, you're probably going to be the idiot. Okay, the resulting, just because, you know, whatever. The mainstream, the, what do you call it? What's the another term for, let's leave it at that. Okay, anyways, the resulting sequence is very close to the distribution of mean distances of the planets from the sun expressed in astronomical units. Here's the body, Mercury. Actual distance in astronomical units is 0.39. Bode's law is 0.4. Venus, 0.72. Bode's law, 0.7. Earth is 1. Bode's law is 1. Mars, 1.52. Bode's law is 1.6. Asteroid Bode, 2.77. Bode's law is 2.8. Jupiter, 5.2. Bode's law is 5.2. Saturn, 9.54. Bode's law is 10. Uranus, haha, I know it's supposed to be Uranus. 19.19, Bode's law, 19.6. Neptune, 30.06. Of course, there is none for Bode's law. Neptune is a peculiarity which we gotta look into. Pluto, 39.44. Bode's law is 38.8. Again, remember they struck out Pluto. Pluto's no longer a planet, so therefore it takes the place of, so this Neptune would actually go into 38.8. But then it won't match up, so it's weird. I don't know what's going on here. 1 AU is approximately the mean Earth Sun distance. Equal AU equals 149.597 times 10 to the 6 kilometers. All planets and asteroid belt fit Titus. This person puts Titus-Bode law, except for Neptune. Anyways, it's supposed to be Titius. Maybe he just doesn't like the name. The term titty. I don't know why I go there. Here's another way to connect Bode's law with Pascal's triangle. Okay, you get the planet, you got Mercury, 1, Pascal's triangle is 1, the binary in, I guess, of K is 1, is it's given here, so it's 0. Venus, 2, or 1 plus 1 is 1. Earth, 3, or let's see, 1 plus 2 plus 1 is 2. How is that working out? I don't get the, oh, I see. Don't worry about it. But basically, yeah, if you add it, use the K of Pascal's triangle, you get Neptune, which is 96. Anyways, I just think it's very peculiar that let's say it is from, let's see, I'm just piecing these things together on the fly, by the way. So 1776 and 1772, and what, let's see, not this one, oh, globe Earth, there we go. As far as where this fits in, and what the thing is, I need to figure out. Okay, so we didn't understand gravity. Gravity wasn't calculated, even though Newton proposed it. Remember, it was Henry Cavendish that actually gave the number, measured gravity, supposedly. But Titus-Bode, they calculated the distance of all the planetary objects within the solar system very exactly without understanding or knowing gravity at all. Okay. Isn't that pretty interesting? Now I need to look into a different thing, which is this calendars? No, it's not connected dots. Is it occult science? Sorry, I'm just looking up some things. All right, here we go. The latest one is 1015. So what I got to do is add in Johannes Kepler, law of ellipses, if I'm going to go ahead and include Titus-Bode. So Titus-Bode, so law of ellipses is 1609. This gets to other things you'll see, I think, an on topic I did 2 or 3 on topics back. You're going to notice that the Mayan calendar and the Egyptian calendars, thousands of years before that, we knew that there was an elliptical system of orbitation. The Mayan calendar, Egyptian calendar, they get it right, 365 days a year on a flat plane, because they believed that the Earth was a flat plane. So Johannes Kepler, law of ellipses, 1609. Let's go ahead and add that in, because then they could actually get something. Maybe that could be used as a reference point. Johannes Kepler and 1609. Shit. All right. Let's go with that. Law of ellipses. There we go. And I'll probably add more later. Okay, so we get this timeline result. But anyways, before we even understand gravity, Titus-Bode were able to figure out the very close distances to the bodies of the solar system in astronomical units. Now, let's curiosity, who came up with the astronomical unit? Origin astronomical unit. All right, originally conceived as the average of Earth's aphelion and perihelion since 2012, has been defined as, well, that doesn't help. Okay, Gian Domenico Cassini. This is from Britannica. That's another thing to add in. All right, let's go ahead and add that in, folks. All right. Astronomical unit. This was given. Okay. 1672. Ooh, that goes back a ways, doesn't it? 1672. Domenico Cassini. That's why they named it after Cassini, off of Domenico Cassini. He's an important figure, right? Or Gian. Let's see. Gian Domenico Cassini in 1662. Italian-born French astronomer, made a reasonably close estimate of the astronomical unit based on a determination of the parallax displacement of the planet Mars, and thus its distance to Earth. I spelled that wrong. Okay, there we go. Close estimate. We will go into parallax later. And let's go ahead and highlight that with the red font. And we're going to also look into the astronomical unit. It all ties in together pretty easily, folks. All you have to do is look for it. Okay. And the astronomical unit. Here, let's see. Let's go ahead and write that down. This is in Ariel 14. Oh, well, let's put it here. And no, we don't want that. And there we go. So that's the astronomical unit right here. Okay. All right. Based on the determination. Okay. So at least they were able to, this fits in, they were able to use their astronomical units with the Gian Domenico Cassini. But it's interesting that when they figure everything out, you know, everything in the, I need to figure out who calculated the distance to the sun first. Why don't we look that up now? Sorry, I'm going a little bit extra. Who calculated distance to the sun? All right. Kristen Huygens, space.com. All right. What? Huygens. And here we go. Is this the same one? 1672. Yeah, okay, so that lines up. Let's go back to Huygens. So in 1653. Oh, this is getting really, really good now, isn't it? It's 1653. Oh, this is afterwards? Wait a second. Oh, wait, yeah, never mind. Let's move that here. Calculated. Venus is peculiar because if you look into the Mayan mythologies and the Mayan calendar, it calculates based on the sun, the moon, and Venus. Why Venus? So we'll get into that later. Distance from Earth to the sun. Again, using trigonometry. Okay, what is the this 1 AU, right? That's what it is. How far is the Earth? Let's see. I need to, let's see. Why do I keep capitalizing it? I don't know. Okay. So that's interesting in the timeline. We've got distance from the Earth to the sun, Oh wait, let's look at the astronomical unit. Oh, so the mean distance from the center of the Earth to the center of the Sun. Who did I say who came up with it? Okay, this person did. All right. Interesting. How does Gian Domenico Cassini, who comes up with the astronomical unit, who doesn't know what the distance from the Earth to the Sun is until Christian Huygens comes up with it, and Christian Huygens didn't come up with it till 1653. We've got another inconsistency here, folks. How does that add up? It doesn't, because it's not going to add up, obviously. That's why I don't believe in the globe Earth model. The next question is, with all this numerology, with all this stuff that we're looking into with the globe Earth declarations, is why is it so easy to figure out? It's so easy to figure out, yet nobody looks into it. Nobody figures it out. I mean, think about it. The astronomical unit is the mean distance between the center of the Earth and the center of the Sun. Okay, but we don't know what the distance to the Sun yet is until Christian Huygens comes out with it, which is 19 years before the astronomical unit is measured. How does that happen? Wait, am I getting things mixed up? I'm getting confused now. Okay, wait. No. This is great, correct? Okay. No, this is right. I was confused. I think. Okay, so all right. No, I get it. All right. Christian Huygens figured out the distance from the Earth to the Sun using the Earth, Sun, Venus triangle, and then Cassini figured out, okay, knowing that, we can go ahead and get the radius somehow from the Sun, and by knowing the size of the Sun. All right, let's see who first calculated the radius of the Sun. Aha. So how did... I hate using Quora. How do you... All right, curious.astro.cornell. My goodness. Short version. Okay, yeah, since radar. You guys had to figure out the radius of the Sun first in order to get this, right? Okay, the first person known to use geometry to estimate the Earth-Sun distance was Aristarchus. Oh, again, we go back to Aristarchus. So then what did Christian Huygens, why you guys mention Christian Huygens if Aristarchus was the first? Oh, because he used the Earth and the Sun and the Moon and not necessarily the Venus-Earth-Sun triangle? Oh, great. Come on, you guys. Distance between Earths to be either that stadia. Okay, go to Eratosthenes again. Scientific measurement of the Earth-Sun distance was made by Cassini. And then eventually radar. Yeah, we're missing something here. What are we missing? We're missing... who calculated... Who calculated the size of the Sun? Who first? I still gotta figure that out. Nope. Here we go. see, I don't want that. Radius of the sun. Who calculated the radius of the sun? Maybe they don't want this to be known, otherwise it'd be too easy to figure out. Astronomy.org. Oh, 93 million. Oh, that's a distance. Oh, Eratosthenes also calculated the sun's diameter. Ah. Sun's diameter. According to Macrobius, Eratosthenes made the diameter of the sun to be 27 times that of the Earth. The actual figure is approximately 109 times. Well, he got it wrong by a lot. Like 4 times? 3 times? 3 times the size? 27 times 3. Yeah, it's got to be more than that. It's 4 times? Because 4 would be... Yeah, he's got about 4 times less than the actual figure. So where did this come from? Ask the astronomer. Archive from the original. Well, they don't tell us who did it. All right, so well, that's bad. Well, let's see. Ariel 14. So I want to know who figured out this part. Do I got hair? Yeah, it's something in my mouth. 20. No, let's go 27. Ask an astronomer. Like because here's the reason why I need to find out who first calculated the size of the sun. Is you can't find out unless you find out the radius of the sun, you can't calculate the astronomical unit. Because the astronomical unit, again, is the mean distance between the center of a spherical object with the center of another spherical object. So that needs to be found out first, but who found that out? And there's a lot of questions that I have that aren't ever answered by the official narrative. People who push the official narrative. Maybe other people will know. All right, let's see. Other questions that I have that haven't been answered are on other episodes of On Topic. Let me see if I can find that. Let's find those videos out. They'll probably just be uploaded videos. We'll see. Gosh, this is a little bit slow. Okay, so who first calculated? So we're still looking at that. That's still a red mark. This is a red mark right here. Because if he got it wrong, the figure for the astronomical units are going to be wrong for quite a bit. Let's see. Let's go with the live uploads. Or the live feeds. Hi, Nathan Oakley. Aren't you doing a show? How come I didn't get email notifications of your second hour? Something. It's Friday. Okay, so I think you air those on the weekend. That's right. All right. Top 5 reasons why you can't go back to the moon. Was it that? I think that might have been it. Top 5 reasons. We're thinking, exploring. Let's see if I get it here. Which I'll have to mute myself again. I don't want to get copyrighted on my own videos. For some reason, things like that happen. Okay. Going over sometimes. What else was weird? Saturn V rockets. Can I get past the Van Allen radiation belts? Destroy their own technology. Can't get past low Earth orbit. Geez, there were like 2 questions that couldn't be answered that I was investigating that I can't seem to find right now. Maybe it is in uploads. Let's see. Nope. Oh, I know. Why? Come on. Why does the moon appear in daylight with the sun? There was a specific one. Let's see. First quarter moon during daytime. So that one, so basically you've got shadow on the moon, right? But it's appearing with the sun. So you've got the moon here, you're looking up about 45-degree angles, and you've got the sun right here, 45-degree angle, approximately, not exactly the same. And the moon has like it's a half moon, basically. So why does the half moon have half shadow on it when the sun's appearing right there with it? Like, how does it create that shadow on the moon during daylight? And that is not ever explained. By official outlets. Now, here's why I hate Quora. Because you've got people, just any average Joe stating credentials, explaining to you what the answer is. The problem with that is no one knows if they're right. Like, if you actually have like a government or a space agency or educational university stating what it is, it's an official outlet because they're sanctioned somehow, some way, right, to be that. But now you've got these so-called, oh, I'm an astronomer, I'm a scientist, and this is why. But that reason why have never been explained by anyone in these outlets. So that's why I want to go with these outlets. It's no one else. Where did you come up with that idea? NASA never said that. No space agency ever said that. No government says that. That explanation never gets revealed to us as the public. So how did you come up with that answer? And the answer will be crickets. All right. I hate it how every time you try to just get these words in red, ends up getting that in red too. There you go. So this is never explained. There's also one other one that never gets explained. I don't know what it was right now. Something else never explained by official outlets. And I gotta figure out what that was. See, that's why when you don't take notes, it can be pretty hard. That's why I start taking notes, because there's just so much to keep track that I'll forget, because there's so much things I look into. Again, I'm not only looking into these things, I'm also looking into a lot of other stuff. This one's ready. I just got to do a thing on it. The north wind, I need to do a little bit more research. The Mayan cardinal colors of the directions, I've got most of it, but I need to look more into it. The cult commonality, Jesus story, I've got most of it, but I got to look into it more. G.K. Chesterton, this one I got to do a lot more research. G.K. Chesterton is kind of an introduction because not many people know about it. I didn't know about him, but pretty cool stuff. Even not Nelson Mandela. Who's the one that did the peaceful movement first with India? Mahatma Gandhi really got inspired by one of his column articles in a newspaper, a column that he wrote. Taking a second look at fairy tales. Yeah, for now I'm taking a second look. There may be a third time I take a look at these fairy tales, but anyways, revisiting Lost Continent of Mu, Lemuria, and Kumari Kingdom. And I think it's just speculation right now. Again, I think Hawaii is the last remnants of this lost continent. I think there must have been another continent that sank. But of course, we're never going to figure that out until we go looking. It's just the same thing with the magnetic North Pole and, of course, the Antarctica. The interesting thing about the number 72 and 73, went over that quite a bit, but not necessarily on the numbers. In the numerology, this ties into the solar calendar quite a bit. I also want to look into the lunar calendar a lot more because I do know that there is a lot of peculiarities with the solar calendar, which is shown here. And let's hide myself here. All right, so there's a lot of peculiarity with a lot of things when we look back into the official history, at least the official narrative of what history is. But the lunar calendar, that's another thing. Also, the Mayan calendar focuses on Venus, not just necessarily the sun and the moon, but Venus itself. So why did they focus on Venus? And so within numerology, again, there's some odd things afoot with Venus, and that doesn't seem to be mentioned very much. All our focus is on Mars, not on Venus. And I just think that's weird. Anyways, that's it. Expect any of these topics to come up soon. And again, we may revisit this again. Just that the number system with Titus-Bode law and the Pascal's triangle and what comes up, that happens to be the distance, very, very, very close distances to the planetary bodies and the asteroid belt. And I forget Neptune. Damn it. I always mess stuff up, don't I? Okay, I'll fix that up later. Anyways, thank you for stopping by and listening, and I'll see you another time.